Greetings, Algebra students. I'm excited to be back with you today, and we're going to be talking and starting off today with classification of real numbers as we talk about general properties of real numbers. The first most basic property of a real number comes to the fact of what you would think when you're counting, and you generally count with numbers that would begin with 1, 2, 3, 4, 5, etc. And as a result, these are the counting numbers. The counting numbers begin with 1 and continue up in that pattern up through infinity. Our next type of number, it would be the whole numbers. The whole numbers begin with the whole, and the whole I would consider to be 0, and then it also includes all the natural numbers, so 1, 2, 3, 4, 5, etc., going up the line. So remember, the whole numbers begin with the whole, and that whole obviously is 0. So that leads us to what happens if we have not just whole numbers, but we also have opposite of positive numbers, which is negative numbers. And those opposite of positive and negative numbers combined along together with the whole are the integers. And the integers obviously would be all the negative numbers, what would be 0, and going up to the positive numbers. Often these are the numbers that you would see that would be on our number line. If we think about other numbers that would be considered past that point, that would lead us to the rational numbers. And rational numbers are the numbers that can be written as quotients of an integer in the numerator divided by a natural number in the denominator. And the reason I say a natural number in the denominator is we don't want to have negatives on the bottom, and we don't want to have a 0 on the bottom. So, how else can we think of rational numbers other than fractions? Well, very simply, they have two qualifications in terms of decimals. Those decimals can either be repeating decimals. You can think about a repeating decimal, like 1/3 is 0.33333. And sometimes we'll put a bar at the top to demonstrate that it keeps on going. Or the other things they can be is terminating decimals. A terminating decimal is a decimal that stops. For example, if you were to think of 7/10 as a fraction, you could write it as 0.7. Or 3/4, you could write it as 0.75. So those are examples of terminating decimals. So rational numbers have three characteristics, as you've seen. They can be a fraction, they can be a repeating decimal, or they can be a terminating decimal. That leads us to what happens if it's not repeating or terminating, and that would therefore be an irrational number. Irrational numbers that are non-terminating and also non-repeating. The most common and famous number of all these is pi, and 3.14159265358, and then it goes on and on and on. And some of you may know numbers further than that, but you notice the numbers in pi do not repeat, they don't terminate, and it keeps on going. In our second one, we have a pattern here with 2 2s, and then 3 2s, and then 4 2s, and 5 2s. And while it is a pattern, that pattern is not repeating, it's just a pattern. And then the third qualification often you see for irrational numbers is when you have the square roots of numbers that are not a perfect square. And I want to emphasize the fact that it's not a perfect square, because the square root of 9 is 3, and that's a rational number. So examples of this would be the square root of 5, the square root of 6, the square root of 7, the square root of 8, not the square root of 9, the square root of 10, the square root of 11, and so on and so forth. Any number that's the square root of a non-perfect square will be an irrational number. So that's kind of the general idea of irrational numbers. We now want to consider three questions that we're going to look at as we compare. Are integers rational numbers? In other words, is any number that's an integer up here also hold the qualifications of a rational number? Well, That's a good question. The answer to that is yes, because the integers are a smaller set of numbers. Now, is a rational number an integer? Well, if you look at this number 1/3, and I look at that number and I say, is that an integer? It's a rational number, but it's not an integer. So, are all rational numbers integers? No, not all. Some are, but not all. And then lastly, are rational numbers always, sometimes, or never irrational numbers? Well, you can see that rational numbers are either repeating or terminating. Irrationals are non-repeating, non-terminating, and those are mutually exclusive. And so they are never, ever, ever the same. So they are very different. So on this next page, we have a flow chart that kind of demonstrates really the differences in how these things are. So if you have a natural number, it's also going to be a whole number, which is also going to be an integer, which will also be a rational. But notice the rational and the irrational are two completely separate buckets. So the number 4, well, the number 4 falls in this category up here. So because it's a natural number, we can say it's natural, it's a whole, it's an integer, it's a rational, and it's also a real number. The number the square root of 7. Well, the square root of 7 falls over here in the irrational bucket. So that's going to be irrational and real, but no other sets. The number 1/3, as we look at the number 1/3, the number 1/3 falls in the rational bucket. And so that's just going to be rational and real. If you've picked up by now, all of our numbers are real. And the number 0.6, repeating. Remember, that's a repeating decimal. And at some point I have to put ... That also falls in the rational bin. And so that will also have the same qualifications as 1/3 did. All right. Well, let's kind of move on here and keep taking a look at these. And let's talk about graphing real numbers. When we're graphing real numbers, we can put any real number on a number line. And so if I'm going to put the number 5 on here as a dot, positive 5, and then I'm going to look at my other comparison, which is the square root of 5. And the square root of 5 falls somewhere between 2 and 3. So that's going to fall right about there. So as we're looking at these two numbers, obviously the number 5 is greater than the square root of 5. So we're going to use the greater than symbol here for the number that we put in between. And the greater than symbol is what's going to be that inequality. When we're comparing decimals and fractions, sometimes it's helpful, well, I shouldn't say sometimes, it's always helpful to convert the decimals and the fractions into a similar type of comparison. So as I look at 7/8, I would have to think, okay, is that greater or less than 0.8? Well, pretty straightforward. If you just take your calculator and you figure what 7/8 is, that's 0.875. Now on our graph, these are very difficult to graph. So I'm going to graph 0.875 right here. And obviously 0.8 is going to be right next to it. But 0.875 is further to the right. So 0.875, sorry about that, it's very small there. 0.875 is going to be the greater one, but our symbol needs to be a less than symbol. So we're going to be less than. Now, I know less than symbols sometimes can be hard to remember, so I want you to think it looks like an L. It points left. And it's less than. So all of those ideas are a helpful way to remember what the less than symbol is. Our next idea talks about opposites and reciprocals. Whenever we see a number that's written with a minus sign in front of it and a variable, we want to talk about that being the opposite of A versus negative A. And so we have opposite numbers, and then we have reciprocals. A reciprocal is defined as 1 divided by the original number or letter. So let's take a look at some examples here. The opposite of 4, if I write it with a minus sign in front of the 4, we would say obviously negative 4. The reciprocal of 4 we would say 1 over the original number, 4, which would give us 1/4. Some people might write that as a decimal, although it's certainly not needed. The opposite of -3 plus a will be +3 minus a. Notice we didn't just take the opposite of one of them, we took the opposite of both. And the reciprocal of that is going to be 1 divided by the original -3 plus a. Some people might write that as a minus 3. It is perfectly fine to do it either way, because notice the a is positive and the 3 is negative in both cases. The opposite of 2/3 can be written as two different ways. You can say -2 divided by 3, or you can say the opposite of 2/3 with the negative out front. Please notice that a negative should never go in the denominator. The reciprocal of 2/3 would be 1 divided by 2/3. However, I never want you to write a reciprocal as a complex fraction. Instead, remember that dividing by a fraction is the same as multiplying by the reciprocal, so we could write this as 3/2. Our next part is 1 5/8. 1 5/8 presents us with a unique and interesting possibility where we can take this and convert it into an improper fraction. So I'm going to say 1 times 8 plus 5. Well, 1 times 8 is 8, plus 5 is 13. So 1 5/8 is really 13/8. So the opposite of that is -13/8, or -1 5/8. You will find in Algebra 2 that we really don't use mixed numbers too much anymore, but we stick to improper fractions. The reciprocal of 13/8 is 1 over 13/8, but we've already realized that leads us to a correct way to write it more as 8 over 13. I hope our opposites and reciprocals make sense. We do have some properties of real numbers, and these properties are important for us to understand. Closure means it stays in that same set. Commutative means things can move around. Associative means you can group them with parentheses. Identity means it doesn't change when you add or multiply by these certain numbers. Inverse, often referred to additive inverse or multiplicative inverse, means your result is either 0 or 1. And distributing means you take the a and you distribute it and multiply it to both parts. These are just terms that we're going to be using this year, and we need to understand that we have those abilities, and those are the properties of real numbers. Using these properties of real numbers, that brings us up to the idea of PEMDAS. I think you'll notice PEMDAS is written with 4 lines here. Often some people read it with 6 lines, but the important ideas are that multiplication and division, along with addition and subtraction, are done together in order from left to right. So let's practice some of these. The first step on example 4 would be to take the part in parentheses and simplify that down to one number. So I think you would agree that 2 squared is 4 and 8 minus 4 is 4. Now the parentheses are down to one number. Now our next step is going to be to do any multiplying and dividing. So we take 24 divided by 4, which is 6, and we subtract 1. Don't subtract the 1 first. Let's now move addition and subtraction from left to right. So we're going to add first and then subtract to get our final answer of 45. On your homework, if you would please work down on your problems and box your answer, that would be great. On letter B, we have 40 plus 16 divided by 8 minus 2 squared minus 1. But the 2 squared minus 1 is in parentheses, as is the 40 plus 16. So I'm going to get that down to one number, being 56, not touching anything on the outsides. 2 squared once again is 4, and 4 minus 1 is 3. Now I'm going to work from left to right for my division. So 56 divided by 8 is 7, and 7 minus 3 is 4. Once again, on your homework, if you would please remember to box your answers and work down, that would be great. Our next problem involves variables. I wanted to bring these up because they are just the same thing we do as we do with numbers, except we work our variables just in order. And so our first thing to do is simplify our parentheses here. 2x plus x, I hope you see, is 3x. Minus 6x squared divided by 2x minus x. Our next thing we're going to do is to square 3x, and that's going to get us 9x squared. I've now done my exponents, and on the next line, I'm going to do my multiplying and dividing. I just have one of them, and that multiplying and dividing piece is right here. Negative 6x squared divided by 2x. I'm going to come off to the side here to help you see this a little bit better. Negative 6x squared divided by 2x is going to give us minus 3x. Now all I have left is adding and subtracting. So that's 11x minus 3x minus x, which is 8x minus x, which is 7x. Our problem D involves another squaring idea. So we're going to be squaring the opposite of 3x. I hope you realize that the opposite of 3x, when we square that, is going to be a positive 9x squared. Please notice that the minus sign carried straight down because it was outside the parentheses. Now we continue, and we have negative 2 squared. In the same way, that's going to be positive 4. We combine our x squareds, and we get negative 10x squared. I hope you remember that there's an invisible 1 in front of the x. Then we have our final part of the problem, which is minus x plus 4. Maybe you remember from Algebra 1 that this would be called a quadratic because of the degree 2, trinomial because of the 3 different terms. Absolute value is our last idea today, and the absolute value is defined as, very simply, the distance away from 0. The distance away from 0. So, you realize that if you were to take a tape measure out, that distance is always going to result in a positive answer. So how far is the number 4 away from 0? Well, very simply, it's 4. How far is negative 9.2 away from 0? Well, it's 9.2 distances away. And then lastly, how far is, wait a minute, we don't have one number there. We have to take and get that down to one number first before we can improvise and take the absolute value. So 3 minus 8 is negative 5. And the absolute value of negative 5 is 5. So that takes us to the absolute value, and we now see that we have taken it after we simplified it down to one number. Our homework guidelines as we look at this are in red. At the top left of your page, you want to put your section number and your page number in your assignment. In the top right of your page, you're going to put your name, print it please, and on each problem we're going to copy the problem, show our work, circle the answer, and skip our line. Now, we're also going to have to make sure that we check our work each problem and correct it accordingly. Use 2 columns per page. Your homework can be found on the whiteboard in the front, on your calendar, in Academy Central, or down here at the bottom of our notes each day. I hope this has been helpful for us to work through this together. Have a great day.